Picture this. It's 1954, and General Motors engineers are huddled in a secret room in Detroit, tasked with an impossible mission. Create an engine that could power everything from grocery getters to race cars, be cheap enough for the average American, yet sophisticated enough to compete with European sports cars. They had no idea they were about to create the most produced, most modified, most beloved engine in automotive history. Over 100 million built, still in production 7 decades later. This is the story of the Small Block Chevrolet V8, the engine that literally powered the American dream. The year was 1954, and Chevrolet was in trouble. Ford had just unveiled their overhead valve Y-block V8, leaving Chevy's ancient inline-6 stove bolt looking like a relic from the Depression era. Pontiac, Oldsmobile, even little brother Buick, they all had modern V8s. Chevrolet, supposedly GM's volume division, was stuck pushing Grandpa's engine while the competition roared past. Ed Cole, Chevrolet's chief engineer, knew they needed something revolutionary, not just competitive, dominant. Something that could be manufactured by the millions without breaking the bank, yet refined enough to power a Corvette. The project was so secret they called it simply Project 265. Here's what makes this story remarkable. The Small Block Chevy wasn't just an engine. It became the Swiss Army knife of American automotive power. An infinitely adaptable design that would power everything from mail trucks to Indianapolis 500 winners, from your neighbor's station wagon to 280 land speed record holders. No other engine in history has been produced in such quantities, appeared in so many different vehicles, or been modified by so many enthusiasts. We're talking about an engine family that spans from 265 cubic inches to 427, from 162 horsepower to well over 1,000 in race trim, from carburetors to fuel injection to modern direct injection. An engine so fundamental to American car culture that you can still buy a brand new one today, 70 years after the first one rolled off the line. To understand why the Small Block Chevy conquered America, we need to travel back to the early 1950s. Post-war America was booming. Suburbs were sprouting like mushrooms after rain. The interstate highway system was about to transform how Americans traveled. Gas was 21 cents a gallon, and suddenly everyone wanted more power. The old inline-6 engines that had served faithfully through the Depression and World War II just weren't cutting it anymore. Ford fired the first shot in 1954 with their Y-block V8. Plymouth had their red Ram Hemi. Even luxury brands like Cadillac and Lincoln were pushing big V8s. But Chevrolet, the brand that was supposed to be GM's everyman division, the one that coined "See the USA in your Chevrolet," was still pushing the Blue Flame 6. Sure, they bored and stroked it, added overhead valves, even slapped 3 carburetors on it for the Corvette. But polishing a turd doesn't change what it is. Chevy dealers were screaming for a V8. They were losing sales to Ford every single day. Ed Cole had a problem. Actually, he had several problems. First, the engine had to be cheap to manufacture. Really cheap. This was Chevrolet, not Cadillac. Second, it had to be light. The frame rails in existing Chevy cars were designed for a straight 6, not some massive V8. Third, it had to be powerful enough to compete, but reliable enough for a taxi to run 200,000 miles. Fourth, and this was the kicker, GM's board wanted it yesterday. Cole had less than 15 months to design, test, and start production of an entirely new engine. Most companies took 3 to 4 years for a project like this, but Cole had an ace up his sleeve. A team of engineers who'd cut their teeth on Cadillac's revolutionary overhead valve V8 of 1949. These guys knew V8s. More importantly, they knew how to make them efficiently. The team included Harry Barr, who'd later become VP of Engineering, and Donald McPherson, who designed the combustion chambers for that Cadillac engine. These weren't just engineers. They were artists who understood that elegance in design meant efficiency in production. The first breakthrough came with the block design itself. Instead of casting separate cylinder banks like the Ford's Y-block, Cole's team created a single casting with a 90-degree valley between the cylinders. This wasn't just simpler, it was revolutionary. The block weighed just 40 pounds more than Chevy's inline 6, but packed 8 cylinders. They achieved this through thin wall casting techniques pioneered in the aircraft industry during World War II. The cylinder walls were just 5/32 of an inch thick, about the width of 2 pennies stacked together. Any thinner and they'd crack under pressure. Any thicker and the engine would be too heavy. The second innovation was the valve train. Instead of complex rocker shaft assemblies, each rocker arm had its own individual stud. Sounds simple, right? This one change eliminated dozens of parts, reduced weight by 15 pounds, and made valve adjustments so easy a teenager could do it in their driveway. The pushrods were hollow tubes, saving more weight. The stamped steel rocker arms cost pennies to produce compared to forged units. Every decision was about simplicity, cost, and weight. Here's where it gets interesting. The combustion chamber design was pure genius. The engineers created a wedge-shaped chamber with the spark plug positioned for optimal flame travel. The valves were canted at different angles, intake at 23 degrees, exhaust at 17 degrees, to improve flow. The compression ratio was set at 8.01, high enough for performance but low enough to run on regular gas. Remember, this is 1954. Premium fuel was a luxury most Americans couldn't afford. The crankshaft was another masterpiece of efficiency. Forged steel, 5 main bearings internally balanced. But here's the clever part. They designed it to be interchangeable across different displacement versions. The same basic crank could be modified with different stroke lengths, and this meant one set of tooling could produce parts for multiple engine sizes. Manufacturing costs plummeted. Now the oiling system. This is where Cole's team showed their racing heritage. Full pressure lubrication to every bearing surface. The oil pump was driven directly off the distributor shaft, eliminating complex chain drives. The filter was a full-flow design when most competitors used bypass systems. Oil passages were drilled directly through the block and heads. No external lines to leak or break. An engine that could survive taxi duty in New York City could certainly handle whatever suburban America could throw at it. By October 1954, after just 15 weeks of development, the first prototype was running on a dynamometer. The initial 265 cubic inch version produced 62 horsepower with a 2-barrel carburetor. That might not sound impressive today, but Ford's Y-Block made 130 horsepower. Chevy's old Blue Flame 6, 115 on a good day. With the optional 4-barrel carburetor and dual exhausts, the 265 made 180 horsepower. Suddenly, Chevrolet wasn't just competitive, they were class leaders. Production began at the Tonawanda engine plant in New York in late 1954. The assembly line was a marvel of efficiency. Where Ford needed 95 minutes to assemble a Y-Block, Chevrolet could build a small block in 72 minutes. The initial production target was 500 engines per day. Within 6 months, they were building 2,000 daily. The cost per unit, approximately $240 to manufacture, roughly $2,600 in today's money. Ford's Y-Block cost them $310 build. The 1955 Chevrolet hit showrooms with optional V8 power, and America went crazy. Chevrolet sold 1.7 million cars that year, outselling Ford for the first time since 1927. The Hot One advertising campaign featured cars literally catching fire from their own speed. Subtle it wasn't, but it worked. The base 265 with Power Glide automatic could push a Bel Air from 0 to 60 in 11.9 seconds. The Power Pack version with stick shift, 8.7 seconds. That was genuine sports car performance in a family sedan. But Cole's team wasn't resting. By 1957, they'd increased displacement to 283 cubic inches by boring the cylinders out. The legendary Tudor A3 arrived with mechanical fuel injection, GM's Rochester Ramjet system. This wasn't some crude throttle body setup. We're talking about individual port injection with a mechanical computer that adjusted fuel delivery based on throttle position, engine speed, and manifold pressure. The result? 1 horsepower per cubic inch, 283 horsepower from 283 cubes. It was a marketing dream and an engineering milestone. That fuel-injected 283 in a 1957 Corvette could hit 60 mph in 5.7 seconds. The quarter mile fell in 14.3 seconds at 98 mph. Top speed, 135 mph. These numbers were embarrassing European sports cars that cost 3 times as much. Ferrari 250 GT from the same year made 240 horsepower from 180 cubic inches and cost $11,000. The Corvette, $3,265 with fuel injection. Let me put the 283's achievement in perspective. In 1957, achieving 1 horsepower per cubic inch naturally aspirated was the holy grail of engine design. Ferrari's legendary 230 Testarossa engine made 300 horsepower from 180 cubic inches, 1.67 HP per cube, but it needed 4 overhead cams, 12 cylinders, and 6 Weber carburetors. The small block did it with push rods, 2 valves per cylinder, and mechanical fuel injection that cost $484 extra. Engineering elegance beating brute force complexity. The small block's true genius revealed itself in its adaptability. By 1962, the 327 cubic inch version arrived, created by increasing both bore and stroke. The base 327 made 250 horsepower. The L84 fuel-injected version, 360 horsepower at 6,000 RPM. But the real monster was the L76 with 11.25.1 compression. 340 horsepower breathing through a single 4-barrel. This engine powered the lightweight 1962 Bel Air 409 killer superstock cars that dominated NHRA competition. Here's what's remarkable about the 327. It shared 90% of its parts with the original 265. Same deck height, same rod length, same basic architecture. This wasn't planned obsolescence. This was planned permanence. A water pump from a 1955 265 would bolt right onto a 1969 327. Try that with any other manufacturer. The 327 became the everyman's performance engine. In a 1963 Corvette split window, the fuel-injected 327 would rocket you to 60 mph in 5.6 seconds. In a Chevy 2 Nova, the 327 created the original muscle car formula. Big engine, small car, relatively affordable price. A 327-powered Nova could embarrass cars costing 5 times as much. Street racers discovered you could bore a 327 out to 331 cubic inches, mill the heads for compression, add a radical cam, and make 400-plus horsepower. The aftermarket exploded. But wait, there's more. In 1967, Chevrolet unveiled the 350 cubic inch version, 4-inch bore, 3.48-inch stroke. This would become the most produced engine configuration in automotive history. The initial L48 made 295 horsepower. The high-performance LT1 of 1970 made 370 horsepower with 11.1 compression and solid lifters. This engine powered everything: Camaros, Corvettes, Chevelle, Monte Carlos, pickup trucks, Suburbans, even boats and industrial equipment. The 350's longevity is staggering. From 1967 to 2003, Chevrolet built tens of millions of 350s. It powered the 3rd, 4th, and 5th generation Corvettes. It won countless NASCAR championships. It dominated Trans Am racing. It powered Indy cars when turbocharged. You could buy a brand new 350 crate engine from Chevrolet until 2015. Nearly 50 years of continuous production. Now here's where the small block story gets wild. The racing community discovered this engine was essentially indestructible when built right. NASCAR teams were making 500 horsepower naturally aspirated from 358 cubic inches by the early 1970s. Drag racers were pushing 600 horsepower with radical cams and compression. Sports car racers loved its lightweight and reliability. Let me tell you about one specific build that shows the small block's potential. In 1988, Reher Morrison Racing Engines built a 287 cubic inch small block for NHRA competition eliminator. Using the original 283 bore size but with exotic materials and CNC machined everything, this engine made 640 horsepower at 8,500 RPM, naturally aspirated. That's 2.23 horsepower per cubic inch from a pushrod V8. The heads flowed 360 CFM at 700 lift. The camshaft had 780 inches of valve lift. It burned 118-octane racing fuel and needed rebuilding every 20 runs, but it proved what the basic architecture could achieve. The aftermarket support for the small block became an industry unto itself. Edelbrock, Holley, Crane, Lunati, Brodix, AFR, Dart. Dozens of companies existed solely because of this engine. You could build a complete small block without a single Chevrolet part. Dart made aftermarket blocks that could handle 1,500 horsepower. Brodix made cylinder heads that flowed better than anything from a Formula One engine. The combinations were literally infinite. Consider this. In 1969, you could walk into a Chevrolet dealer and order a ZL1 427, an all-aluminum big block that made 130 horsepower and weighed less than a small block. Only 69 were made for Sopo Camaros. Today, one of those engines is worth $100,000. But here's the thing, you can build a 427 cubic inch small block using a Dart block that makes 700 naturally aspirated horsepower for about $15,000. The modern aftermarket has exceeded what GM's racing division could do 50 years ago. The small block's influence extended way beyond Chevrolet. When Ford needed a new racing engine in the 1960s, they benchmarked the small block. When Chrysler designed the LA series, they studied the small block. Even Ferrari admitted to analyzing the small block's valve train geometry when developing their Dyno V8. Imitation is the sincerest form of flattery, but perhaps the small block's greatest achievement was democratizing performance. Before 1955, if you wanted a fast car, you needed money, lots of it. The small block changed that equation. A kid working at a gas station could save up, buy a used 327, rebuild it in his garage, and have genuine performance. The knowledge was freely shared in magazines like Hot Rod and Car Craft. Speed shops popped up in every town. The small block created car culture as we know it. The transformation wasn't just mechanical, it was cultural. The small block powered the muscle car era. It soundtracked American graffiti. It made heroes of drivers like Junior Johnson and Richard Petty. When Bruce Springsteen sang about a 396 and a 4 on the floor, every American knew exactly what he meant. The small block wasn't just in our cars, it was in our music, our movies, our national identity. Think about the sheer variety of vehicles that use this engine. A 1969 Camaro Z28 with the DZ302 screaming to 7,000 RPM on a road course. A 1972 K5 Blazer with a 350 crawling up a mountain trail. A 1996 Impala SS with an LT1 cruising at 90 mph, getting 28mm rejeat. A 2002 Corvette Z06 with an LS6 making 405 horsepower from 346 cubic inches. Same basic architecture, infinite applications. The evolution continued into the modern era. The LS series, introduced in 1997, was still recognizable as a small block despite being all new. Same 4.4-inch bore centers, same 90-degree V8 configuration, same pushrod valve train, but now with aluminum construction, coil-on plug ignition, and sophisticated engine management. The LS1 made 345 horsepower from 346 cubic inches, while meeting emission standards the original designers couldn't have imagined. The LS series took the small block formula into the 21st century. The LS7 and the C6 Corvette Z06 made 505 horsepower from 427 cubic inches. Naturally aspirated, emissions legal, with a 100,000-mile warranty, the supercharged LS9 in the ZR1 made 638 horsepower. The current LT5 in the ZR1 makes 755 horsepower, all direct descendants of that original 265. Here's a mind-blowing statistic. Between 1955 and today, General Motors has produced over 100 million small block V8s. If you line them up end to end, they'd circle the Earth twice. The economic impact is incalculable. Not just the engines themselves, but the entire ecosystem. Machine shops, speed shops, racing teams, aftermarket manufacturers. We're talking about a multi-billion-dollar industry that exists because Ed Cole's team got it right the first time. The small block also revolutionized manufacturing. The thin wall casting techniques developed for it became industry standard. The modular design philosophy influenced every engine that followed. The idea that one basic architecture could span from economy to performance applications changed how manufacturers approached engine families. Even Toyota studied the small block when developing their UZ Series V8. Let's talk about reliability for a moment. Taxi companies in the 1960s reported small block-powered Chevrolets routinely exceeding 300,000 miles with basic maintenance. Police departments loved them because they could idle for hours, then accelerate to 120 miles per hour without missing a beat. The U.S. military used small block-powered vehicles because they could run on practically any fuel and be fixed with basic tools. This wasn't just an engine, it was a workhorse that happened to be capable of winning races. The racing success alone fills books. NASCAR championships, 29 manufacturer titles for Chevrolet, most powered by small blocks. NHRA championships, countless across every category from stock to pro stock. Trans Am championships, Chevrolet dominated with 302 and 350 powered Camaros. IMSA, small block powered Corvettes won 8 consecutive manufacturer championships. Even in Formula 5000, where exotic engines were common, the simple small block Chevy was competitive, but perhaps the most telling tribute to the small block came from its competitors. When Ilmor Engineering needed an engine for IndyCar racing in the 1990s, they started with small block architecture. When McLaren needed an engine for the Can-Am series, they used a small block-based unit. When countless boutique supercar manufacturers needed reliable power, they turned to the small block. Reliability, power, and parts availability trumped exotic engineering every time. The human stories behind the small block are equally compelling. Ed Cole went on to become president of General Motors. Zora Arkus Duntov used the small block to transform the Corvette from boulevard cruiser to world-class sports car. Smokey Yunick found ways to make small blocks do things Chevrolet engineers said were impossible. John Lingenfelder built small blocks that made 1,000 horsepower on pumped gas. These weren't just engineers and mechanics. They were artists whose medium happened to be aluminum and steel. Consider the economic democratization the small block enabled. In 1970, you could buy a used 327 for $100 at a junkyard. A rebuild kit cost $150. Performance parts from J.C. Whitney or Summit Racing were mail order away. For less than $1,000, a working-class kid could have a genuinely fast engine. Compare that to a Ferrari engine rebuild that cost more than most people's houses. The small block made performance accessible to anyone willing to turn wrenches. The cultural impact extended beyond America. Australia fell in love with the small block-powered Holden Monroe. Brazil built their own versions for Chevrolet Opalas. Even behind the Iron Curtain, people smuggled in small block parts. The engine became a symbol of American industrial capability and innovation. When the Berlin Wall fell, one of the first things East Germans wanted to import was American V8 engines. Today, in 2024, you can still buy a brand new small block-based engine from Chevrolet Performance. The ZZ632 crate engine makes 1,004 horsepower from 632 cubic inches. It costs $37,758 and comes with a warranty. Think about that. You can order a 1,000 horsepower engine online and have it delivered to your door. It bolts into any chassis designed for a small block since 1955. Try doing that with any other engine family. The small block's influence on modern engines is undeniable. Direct injection, variable valve, timing, cylinder deactivation. These technologies were all tested on small block architectures first. The current LT2 in the C8 Corvette makes 495 horsepower from 376 cubic inches while getting 27 mpg highway. It idles at 600 RPM like a luxury car, but revs to 6,150 RPM like a race engine. It meets California emission standards that are stricter than anywhere else on Earth. Yet strip away the technology and you'll find the same bore centers, same deck height, same fundamental architecture from 1955. So what was actually going wrong in the auto industry that the small block fixed? Everything was too complex, too expensive, too specialized. Ford's Y-block had exhaust passages that ran through the intake manifold, causing overheating. Chrysler's Hemi was magnificent but cost a fortune to produce. European engines were highly sophisticated but needed constant maintenance. The small block proved that simple, reliable, and affordable could also mean powerful and adaptable. It was the engineering equivalent of the Swiss Army knife. Not the best at any one thing, but good enough at everything to become indispensable. But the real story wasn't just the engine. It was what the engine enabled. The small block powered the muscle car era that defined American automotive culture. It made drag racing a national pastime. It turned NASCAR from regional entertainment to national obsession. It powered the boats that made water skiing popular. It ran the generators that powered carnival rides. It was quite literally the heartbeat of America for 7 decades. The small block also changed how we think about engines. Before 1955, engines were expected to last maybe 50,000 miles before major overhaul. The small block routinely doubled that. Before 1955, modifying engines was the province of wealthy racers. The small block made every shade tree mechanic a potential speed merchant. Before 1955, engines were application specific. The small block proved one design could do everything from grocery getting to Grand Prix racing. The engineering philosophy behind the small block influenced industries beyond automotive. The modular design concept appeared in everything from computers to furniture. The idea of planned adaptability rather than planned obsolescence became a design philosophy. Business schools teach the small block story as an example of platform engineering done right. Create a solid foundation, then iterate endlessly while maintaining backward compatibility. There's something profoundly American about the small block story. It wasn't the most sophisticated engine. European designs had overhead cams and exotic materials. It wasn't the most powerful. Chrysler's Hemi made more power per cube. It wasn't the most efficient. Smaller displacement engines got better fuel economy. But it was the best compromise, the most adaptable, the most democratic. It embodied American values, practical innovation, accessible performance, infinite customization potential. Looking back after 70 years, the small block Chevrolet V8 stands as perhaps the greatest automotive engine ever created. Not because it was perfect, but because it was perfectly adaptable. Not because it was the most advanced, but because it advanced with the times while maintaining its essential character. Not because it was exclusive, but because it was inclusive. Powering everything from the humblest work truck to the most exotic race car. The small block didn't just power vehicles, it powered dreams. Dreams of going fast, dreams of building something with your own hands. Dreams of freedom on the open road, dreams of victory at the drag strip. For millions of Americans over 7 decades, the small block wasn't just an engine. It was possibility cast in iron and aluminum. It was the mechanical embodiment of the American belief that with hard work and ingenuity, anything was possible. Today, as the automotive world pivots toward electrification, the small block's reign is finally ending. The C8 Corvette will likely be the last production car with a traditional small block derivative, but its influence will persist long after the last one's built. The engineering principles it established, the manufacturing techniques it pioneered, the cultural impact it created, these are permanent contributions to human achievement. What's remarkable is that Ed Cole's team accomplished all this with slide rules and drafting tables. No computer simulations, no finite element analysis, no computational fluid dynamics. Just brilliant engineering, careful testing, and an understanding that sometimes the best solution is the simplest one that works. They created not just an engine, but an ecosystem. Not just a product, but a phenomenon. Not just horsepower, but heritage. The small block Chevy conquered America not through force, but through faithful service. It earned its place in history 1 mile at a time, 1 race at a time, 1 satisfied customer at a time. It proved that great engineering isn't about complexity. It's about solving problems elegantly. It demonstrated that true innovation isn't about reinventing the wheel. It's about making the wheel so good that it doesn't need reinventing for 7 decades. So here's to the small block Chevrolet V8, the engine that powered American dreams from tail fins to smartphones, from From carburetors to direct injection, from Eisenhower to Instagram, a mechanical marvel that proves simplicity and sophistication aren't opposites but partners. An engineering achievement that shows the best designs aren't just built to last, they're built to evolve, adapt, and inspire for generations. What's the most impressive small block build you've ever seen? Was it a numbers-matching restoration, a 1,000-horsepower monster, or maybe your dad's old pickup that refused to die? Drop a comment below and share your small block story, because after 100 million engines in 70 years, everyone has a small block story. And if you want more deep dives into the engines that changed the world, make sure to hit that subscribe button. Until next time, keep those pushrod V8s singing their song of American thunder.